Already the recording started. Fine. In our last class, we started the semantics analysis part. We seen that that what type of errors are being cast in semantics analysis phase, and then we moved to the different categories of semantics analysis segments. Uh, that we seen that in the semantics analysis, in the syntax analysis, basically we generate the abstract syntax tree, but in semantics analysis we form a complete syntax tree. And in syntax analysis part, the tree is being prepared and we decide that whether I have to approach in top down manner or bottom up manner, and the associated parts are to be fired. In the semantics analysis, the semantical rules, last class you have seen that in the left side the production rules were there and the right side the semantical rules were there. So we are firing the semantical rules to construct a specific tree based on a certain string, because string means that in for example someone has asked you to give to get an expression from 2 plus 3 asterisk 5, what is the value for that specific string or the input expression. In order to evaluate the compiler, how a compiler can evaluate that value. For that, it first generates a syntax tree. First, the tokens are generated, then it forms a syntax tree. In order to evaluate the syntax tree, it finds that the bottom-up parser would be sufficient to find the values. So, associated grammars in the bottom-up parsers and the the syntax rules are also embedded. Also, definitely they are embedded. Those are fired, and is abstract syntax tree is being prepared first. Then after, the semantical rules which are embedded against each production rule are being fired from bottom up, and finally the root node value is being evaluated. Right. So this is the process. Last day we started with that discussion, and we seen one example that how the semantical rules are applied in order to evaluate the what I wanted to mean that the uh, value of the entire tree or the value of the root node, right? So today we will be moving further and some more examples we will be looking at to get some clear picture. Okay. হ্যাঁ ম্যাডাম বলুন। Okay. I hope the screen is being shared. I had to mute because some urgent calls are there. Okay, the screen is being shared. Everything is fine. I hope. In the last class, just I'm scrolling up to make you remember that what we started. Okay, I had to open in Microsoft Edge, otherwise it will not be possible. Okay, open with Microsoft Edge. Fine, now it is fine. Okay. Now, in the semantical analysis, that it was categorized into two segments. One was syntax directed definition, another was translation scheme. Right? These two categories were there. So I have not discussed anything on semantic translation scheme, correct? I will be talking on that later. Here, under the syntax analysis, yesterday just I opened up. I said that we will be moving on the S attributed definition, first segment first, and under that S attributed definition, two properties are there. One is called synthesized, another is called inherited. Correct. But yet I have not talked anything on what is called synthesized attribute and what is called inherited attribute. So I will be discussing on those attribute properties later. First, let us understand that how this evolution of the tree beings takes place under the S attributed definition. Correct? Okay. Yesterday, these examples we had seen, this example number 40, I hope you can remember. Okay. Now, next example I am moving here. Example number 41. Okay. Let I am writing all the productions one by one so that it will be easier for you to track down the development. Okay, here is the pen. Let me connect first. Let there is a production set, a grammar is being given, and for that grammar let a grammar be G. For that grammar the production rules are like E generates E plus T, and E also can generate T. T generates T asterisk P, also T generates P, and some more rules are there. Okay, P generates bracket and E. Also P can generate 0 or even P can generate 1. These are the production rules, means by which I can form a tree, right? Okay, let me take less space here so that I can accommodate everything here. Okay. Now for the first E to E plus T, what they are telling, if there is E to E plus T, that means we are adding E1 dot val with E2 dot val. Okay, so E to E plus T means E dot val. E dot val means the value we are calculating is equal to E dot val. I can tell E1 or E2, that is up to me. E dot val plus T dot val. This is the semantical rule. E to T, it means E dot val equal to T dot val. For T star P, it is written as T dot val equal to, okay, here they have written T dot val asterisk P dot val multiplied by P dot num. P dot num. You see that here only two parameters are there, T and P, but here three parameters came in the semantical rules, right? Then here it is written P dot val equal to here E dot val. E dot val. Here also they have written P dot num equal to 1 and P dot val equal to 2. Okay, it is written for, let me check, it is written for, okay, E dot val T to P. Okay, there is a mistake is there in my writing. I have to change it. I have to change a little bit here because I jump one sequence. Here it was T to P means here it was T dot val equal to P dot val multiplied with P dot num. Then here it was P dot val equal to E dot val. Here it will be for 0. The two rules are there. P dot num equal to 1 and P dot val equal to 2. For 1 also, P dot num equal to 2 and P dot val equal to 1. Okay, so for this first production number 1, this is 2, this is 3, 4, 5, 6, 7. Also here I am marking the indexing. Here this is for 1, this is 2, this is 3, this is 4, this is 5, this one is for 6, and this one is for 7. Okay, now you see that first one thing you need to consider here, that val is a parameter I am every time I am telling. So val is a parameter. If I am take another parameter is there is num. So here num is also an parameter. So here in this production rules for the grammar that I have written, two parameters are there, val and num. These are called production rules. These are called semantical rules, but two parameters are there, val and num, to be evaluated. Now, few minutes back, when I said that S attributed definition has two segments, one is called, or two attributes, I said. One is called inherited attribute and synthesized attribute. So these are called attributes. These val and num, these are called attributes, because attribute means based on this val and num, the tree will be formed and the values, subsequent values will be evaluated. Correct? So one thing is be clear with the idea that val and num here are the parameters or the attributes. Correct? We had to consider. Right. Now, what is inherited and what is synthesized, yet not I have spelled out. Correct? I will be discussing that once this problem is being solved. Okay. Now, let someone ask me that I have to design a tree for 1 asterisk 0, right? For 1 asterisk 0, I have to design a tree. So I am taking this example that I have formed just here. Okay, just you, I hope you can check from this example also. I hope that ample space is not here. Okay, let me check whether I can do it in this small space or not. Okay, I'm trying to make it here small. Okay, I'm starting with E. E is generating T, then T is generating T, here it is generating P. From T, it is building P. From P, I am obtaining 0. And here also I missed one character. Here is asterisk was there. And from P it is 1. From P, I am obtaining 1. Right? How I make it? Just see that E to T is an expansion. So E to T I started. Then I started with T to T star P, the third production I used here. Then T can generate P. So fourth production rule I applied. P can generate either 0 or can 1. So here P generates 1, P generates 0. So subsequently, if I want to evaluate the infix operation of the tree, if I drop the node perpendicularly, you know that it will give us, this is 1 asterisk 0. So my actually assumption or my desired string was 1 asterisk 0, that I have obtained already. Now the thing is that the tree is being formed here, but what will be the value of the tree? Correct. This tree has two parameters. One is called num parameter, another is called val parameter. So for both the parameters, I need to evaluate the tree. Right. Now you see a interesting phenomena. It will be good if I can draw the tree in the right side, because you can get the idea, because you can see simultaneously here. Let me try once again, whether I can draw the tree here or not. E to T. Okay, T, this is asterisk, here this is P. T is generating directly P. P is generating 0, and here P is generating 1. Fine, I have done it. Okay, so I'm erasing the second tree that I have designed here. Okay. Okay, let me change the color. Hmm. Okay. Now see that for this tree, I have to evaluate the tree functionality, and two attributes already we have said, that one is called val attribute, another is called num attribute. There is no doubt with that, right? Now, if someone asks us to evaluate the tree, you just see how I am evaluating. If I want to evaluate the e to t first, e generates t, whether I can do it. So if e to t, the second rule I am applying, then e dot val equal to t dot val. So e value, if I want to obtain, then the t value need to be calculated first. Correct. So that means that e val, this val attribute is dependent on the t val attribute. That means one thing be sure with that, that the val is coming from bottom up. So the val attribute that I need, it will be obtained from bottom up manner, because t dot val will be coming to the e dot val. Or even if I want to execute, for example, the rule number 5, P2 bracket E. So P dot val equal to E dot val. Though that is not applied here, but you still can check that E val to be evaluated first, then P val. So that means val attribute to be evaluated from bottom up manner. Okay. Now E to T, this function I cannot check first. So let whether I can design T star P or not, T to T star P. So rule number 3, T to T star P. It means T dot val. Okay, if I want to calculate val, then T dot val, this val into P dot val into P num. But none of the attributes are available with me, correct? So here I cannot decide anything. So T to P, here T to P is there. For T to P, T dot val equal to P dot val asterisk P dot num. Still it is not available. Correct. Now P to 0, when P equal to 0, then P num equal to 1. Okay. When P to 0, you just see, when the value P to 0, then P num equal to 1 and P val equal to 2. So that means here I am getting I am writing V for val, N for num, correct? So the val I am getting here 1 and num value I am getting here, val is 2 and num here I am getting, okay, and val equal to 2 and num equal to 1, right? And this value that I have obtained here, both n and v are coming from bottom up manner, right? Why bottom up? That is very important. Why important? I will be telling it later. Now p equal to 1, here also for the seventh rule number 7, num n equal to, here the n equal to 2 and v equal to 1, right? So this is the value that I have obtained, and also the value is coming from water combiner here also. Now t to t star p, here the rule number 3, a t dot val, it means t dot val multiplied by p dot val. Okay, so before evaluating this one, I need to evaluate t to p, because this node value to be calculated. So t to p, what is the meaning of t to p? Here rule number 4, it means t dot val equal to p dot val into p dot num. So that means t dot val, here I can calculate the value for t by multiplying p dot val by p dot num. What is the p dot val? It is 2 and p dot num it is 1. So 2 multiplied by 1, that means v equal to 2 here. So the v for this node t I can obtain 2, but there are no comments against what is the value for n. If they are not given in the semantic rules, we cannot calculate. That is Very simple. Had they given the num attribute corresponding to that node, we could have calculated. Now moving to the next segment. T to T asterisk P. T to T asterisk P. Here, rule number 3 when I'm applying. T dot val equal to T val, P val, P num. Okay, T val means this T val. That means here we are calculating the value V for node T. It will be 2. That means the first segment multiplied by P val. P val means T val multiplied by P val. P val means here val is equal to 1. So multiplied by 1. I am coming from, it is getting from this P node value. Multiplied by P num. So P val also has a num that is 2. So multiplied by 2. So that means the value is 4. Then T dot val, that means here the node T dot val has a value of 4. Right? Now E to T extension is there. E to T expansion was there. E dot val equal to T dot val. So that means here the val is we are obtaining it is 4. Right. So now if someone asks you what is the val attribute value for the root node, then you will say that the value is 4. But if someone asks you what is the num attribute value for the root node, you are not able to decide because the associated semantics rules are not written. Correct? Now one point here I will mark here, that if some attributes that to be calculated are coming from, let I am writing inherited first and synthesized, because the time has come to decide what is inherited and what is called synthesized. Now inherited means, just remember IPS term and S for SC term. Supreme Court, you can remember that this I and also this S, I used to remember by this notation. I for inherited, S for synthesized. IPS, this is civil service examination. Someone passed, he is going for the IPS, and this is the Supreme Court. Okay. So IPS means if attribute can be called inherited, attribute means a val or num can be called inherited if it is coming from either from parent or from sibling. S stands for sibling and P means parent. But here the C stands for child, right? That means an attribute can be called synthesized attribute if the values are coming from the child. What do you mean by sibling? If I consider this node T, it has a sibling P. For P, the sibling is T. For T and P, the parent is T. Okay. For this T, the child is P. This P that I am marking here. I hope you can understand. This is called child, and the upper, if I am tracking back, it will be called parent. Right. Now, in the example that I have shown, in that example, two attributes were there. One was val attribute, another was num attribute. But both the attributes, what we have checked, that both the attributes, whether the attributes are coming from child or coming from parent, they're coming from child. Because once I want to calculate the value for T dot val, for val attribute I am considering, the T val is coming from P val, this P val, right? And this P20, this is a static assignment. So that means one thing be sure, that this val attribute that I am operating, that means it is bottom up. Bottom up means coming from child. That's why every time I was specifying. Val attribute is a synthesized attribute. But num attribute, also the num attribute, we have seen two cases. Here also, when we calculate the num, the num also was coming from the bottom part, right? Because P dot num was a static assignment 2 and P dot num was static assignment 1. And based on the assignment, the T value was calculated. But though here categorically the first assignment was being made, but still some more semantical rules to be embedded here to decide whether num is a synthesized attribute or inherited attribute, because based on the static one-time assignment, sorry, not here, this one, I cannot say that whether num is a synthesis attribute or inherited attribute. But if that is not given to you in exam, then in the worst case scenario, you can take that num is appearing here. And when I am calculating the num for here, num is appearing here. When I am calculating the num for P, the value is coming from bottom to up. So also num can be categorized as a synthesized attribute. But more rules to be given, because all the values I have calculated on val, e dot val, t dot val. Some places if I had calculated t dot num, then I could have obtained the real test that whether the num is a synthesized or inherited. Okay, but here I can take val is be sure that synthesized. There is no doubt with that. But now we can take a positive sense and we can say that here in this example. But in most, if you are appearing in gate questions or like that, they never will ask you that whether num is a synthesizer or not, because they would have given more semantical rules based on num. After that, they will ask you to judge. Okay. So inherited means the values are coming from parent and sibling. Synthesized means it is coming from child. Okay. I hope the idea is being clear now. Now let us see one more example on it. The same with the same example I am carry forwarding with the same example number 41, right? Now if they have asked you to generate a string for 1 asterisk 1 plus 1, this is being given, right? For this, I have designed a specific tree here. You can check out. This is a tree that I have formed, correct? And in the same way, you can evaluate the value of the tree. In the questions, they may ask you what type of questions may come. Either they can ask you that whether val and nums are synthesized or inherited attribute. This type of question may comes. They may ask you to find out the value of the root node, the val attribute of the root node, or the num attribute of the root node, correct? Or they may also ask you to design a syntax tree based on the string given and show us the evolution of the tree. Evolution of the tree means the way that I have shown here, you need to show it. Correct? The idea is clear, I hope. And some example I have given here, I hope you should solve it. That the root value already I have calculated, it was 4. And also the e dot val for the string, this one, question number B. Here the right answer is 6. I have marked it. You can do it and you can check. Also, you can find the final value here I have obtained as 6. So it is fine with us. Now, fine with us. Now fine with us. Now let us see some more example on it. This example will be very good for you to understand that inherited attribute property and synthesis attribute property. So example number 42 here I am taking. Okay. Now see in the example number 42 that for this production I am marking is production number 1, production number 2, 3, this is 4. For each production, 2 set of rules are given. One is for val rule, one is for num rule. Here also one is for val rule. Here 2 sets of num rule. E2.num, T.num, 2 set of num rules are given. Correct? Here E2T is there. Here the 5th production is this one. This is the 6th production. This is the 7th production. Right? Now they have asked you to find out the value for the string 3. And also I am asking the first question is there, which attributes are inherited and which are synthesized. So 2 attributes are there, one is num and val in the example, and you have to tell first that what are their attribute types, synthesized or inherited. Second thing, what will be the value for the string 3. Third question is what will be the value for this string 2 plus 4 asterisk 3. I hope both the examples I have solved out here, you can do it. But still I am showing that how it is possible. Let me draw a diagram first here so that I can make you understand. Second question I am solving, first and second. The third one you can solve in your home. because there is a shortage of space here. S to E, let E to T, T to P, and P to I. Okay, this is the flow diagram that I have made out here. Okay. Now see this example that I have shown here. The first question was which attribute was inherited and which one is synthesized. So this answer you can only give once you design a tree and evaluate the tree. Based on it you can decide. Okay, so that better, it will be better if I solve the example number 2 first, means the option B first, then I will decide which one is synthesized and which one is inherited. For value for 3, let I is generating 3, you just check how I have expanded it. So the first expansion was rule number 1, S to E, the first expansion. Then the second expansion was rule number 3, first rule number 1, rule number 3, E to T. Then T to P, here also T to P, rule number 5, T to P, and then onwards P to I, and I stands for the numeric value. P means, I means, you can assume it is 3. Directly correct. So here I am writing for your understanding purpose. Here P means it is 3. Correct. Now I will evaluate the tree value first. Now you see one thing, that here S to E is there, the first expansion. Now S to E, let two properties I have to calculate for each node. One is val, another is num. I am marking val and num. Here also, here is val, another is num. Here also it is val, another is called num. Here also it is val and another is num. Correct. Now you see, for calculating the val, S to E expansion, what they are telling, S dot val equal to E dot val. So S dot val, if I want to calculate this val, then if the S dot val, it is dependent on E dot val. So that means for calculating val, I have to go, that means to calculate the val, I have to move down. Move down means the value will be coming from the bottom up. Because when you are pumping some water, to get some water from your pump or by your hand pump, then you have to move down. Move down means in way to search the water. You are moving down means in way to fetch the data or you need to fetch the water, you have to approach in bottom up. Correct? So the approach is bottom up. So E dot val is dependent on, so S dot val is dependent on E dot val. So the dependency graph you can just consider. You may forget rest of the sentences, whatever I have said. Right? So the val will be coming from bottom up. That means bottom up means from the child. That means I can decide the val is, I hope you can remember, IPS at SC. S synthesized, I for inherited, C for child, P for parent and sibling. So the val is coming from the child. So that means val can be categorized as a synthesized attribute. So within S I am writing that means synthesized attribute. Right. So in the S dot val I cannot calculate here in the very first stage. So num can I calculate? Yes, I can calculate num because E dot num, there is a static assignment. E dot num is already 1 is given. Right. You see that E dot num already been given, but val is dependent on E dot val. So num is given. Okay, now let's see the second expansion. We cannot comment on num now. Let's see some more cases. E to T. So E to T, you know, to calculate E to T. So E dot val equal to T dot val. So again, the val for E is dependent on the T. So here the val was dependent, here the val was dependent, and here also the val is dependent. Once the T dot val is calculated, then it will be coming to the E dot val. Now at the same time, for the second scenario, T dot num equal to E dot num plus 1. T dot num here equal to E dot num. Where is E? Oh, that is a parent. E dot num plus 1. correct? T dot num, you just see that e to t expansion is there. T dot num equal to e dot num plus 1. So t dot num I can calculate if I find the e dot num plus 1, right? So that means the num that I am calculating, so it is coming from the data is the num data is flowing from bottom up. That means the num attribute, it is coming from bottom up, so it is comes under the inherited parents or sibling. So it is coming from parent, correct? So if it is coming from parent, then it is fine, no problem with that, right? Now I hope that you have understood what I am telling, that s dot val, sorry, the val was synthesized because the val was coming from bottom up, and num it is coming from top down, that's why it is inherited, correct? Based on it, I hope that you can evaluate the tree value. I hope that will not be a big deal to calculate the value for e to t, because you can check here already I have solved the problem, s2e, okay. Here already I have solved the problem. Okay, I have written this here. I should not have written here. I should have written here. S2E was there actually. Uh, I should write it in this way. You just see that here I should have written that val equal to no value we are getting. Num value no getting. But e dot num it is mentioned. Na? E dot num. But I put it in s dot num. So it was e dot num equal to 1. Just check it. Not s dot num. Initially I put it in here, but it was a mistake. So that's why I have erased this segment, because you need to check the rule, the semantical rules that is being embedded. This is a and as per the semantical rule, here as per the semantical rule, you just see, okay, it's not coming. Here as per the semantical rule, you just check, they are calculating the e dot num, not s dot num. If we had written s dot num, then I could have written the s dot num equal to 1, right? But it is e dot num. Let me take the eraser. The eraser. Check. Yeah, it is here. So e dot num equal to 1, it is being calculated. Now for the third rule, e to t, they are telling e dot val equal to t dot val. So e dot val we cannot calculate. Let me erase these parts because this is not true. Now e to t, they are telling that t dot val I can calculate. T dot val. So that means t dot val equal to e dot num. So t dot val means this one. Sorry, t dot num. T dot num we can calculate. So t dot num is this one. This means e dot num. E dot num is 1 plus 1. This is constant 1. So plus 1, that means it is 2. So t dot num we calculated as 2. But the val field is yet not filled. This field is still vacant. Okay, now let us see T2P expansion. For T2P expansion, T dot val equal to P dot val. Again, the val again is dependent. This P val is dependent on T val. Or sorry, T val is dependent on P val, because this T dependent on P. That's why the arc is given. That P from P, the arc is towards T. Now P dot num. P dot num here. P dot num means this field. P dot num equal to T dot num. T means T dot num is this one. This is 2. Plus 1. That means 3. Right? Okay. Now P2I. The seventh production. P2I. P2I means P dot val. EC. P2I means P dot val. Here we are calculating P dot val. So here we are calculating the val. P2I extension is there. Here we are calculating the P dot val. That means here we are calculating this val parameter here. This val. What is the val? Val means I. What is the I? I stands for 3. So it is 3. Divided by P dot num. What is the P dot num? P dot num is 3. So divided by 3. 3 by 3 means 1. So P dot val, now we find it out, that is 1. Right? Now we have to check T2P expansion because val field is still open. T2P expansion was there. And we've seen that P dot val was coming to the T dot val. So that means P val will be coming to the T dot val. That means here it will be the 1, it will be here. For E to T, okay. For E to T, again the same thing. T val will be coming to the E val. Okay, T val is 1. That means by default, again it will be 1. Not by default, by the assignment. Right. In the same way, S2E, S2E, S dot val. E dot val will be assigned to the S dot val. So here the val value we are calculating and the value will be 1 again because this one assignment is coming here. So the final root node value for S we have obtained as 1. But what scenario we have seen? How the evaluation is being done? And we have seen the num as a, we find it out that num as inherited attribute and val as a synthesized attribute. Correct? So this example we have seen, and I hope you should solve one more example here. That example I have given, this is a on the same production rule that I have shown on example number 42. The same using the same production rule, but it a big better big expansion is given. I hope you should solve it and it will get the idea clear. From exam point of view, what sort of questions are being asked? That they first ask you to design the syntax tree and evaluate the tree nodes. They may ask you to find it out what is called is synthesize, what is called inherited attribute, or they may even ask you to get an expression. For that expression, what will be the root node value, right? So just I am concluding this topic today. What we have discussed till so far is what is called inherited, what is called synthesized attributes, and the flow of the data throughout the tree. Okay. Tomorrow, on the next class, tomorrow is Saturday and Sundays are there. So tomorrow, I will not be uploading any videos. On Monday, I will be uploading the videos. I have to prepare it and I will be uploading. I have to record it. Prepare means I have to record it and I will be uploading. Some more examples on synthesize or inherited, I will try to accommodate. And you should follow this document from where I am teaching. That will be sufficient for you. Okay. Thank you very much.